morning, everyone. My name is Ayana, and I'm going to discuss about WebView loading a website. Introduction to WebView. First of all, what is WebView? WebView is an embeddable browser that a native application can use display web content. Think of it as a component that render HTML, CSS, and JavaScript right inside your mobile app without opening a separate browser application. In app browser, it allows you to open web pages within your application, providing a seamless user experience. Native component. It's a native UI component for Android and iOS powered by the system's underlying web rendering engine like Chrome and Safari. Why use WebView in mobile apps? Code reusability. Share web-based features and content across your website, Android app, and iOS app without rewriting the code for each platform. Rapid development. It's often faster to develop and deploy a feature using web technologies than building it natively from scratch, especially for content-heavy schemes. Dynamic content updates. Update content or even functionality by just deploying changes to your web server. No need to submit a new app version to the app stores. Core concepts of WebView. Native layer. The Android or iOS application manages the WebView size, position, and lifecycle. Can send data to the web pages. Web layer. HTML, CSS, and JavaScript content loaded from a remote URL or local files can send data back to the native app. The connection between these two layers is often called the JavaScript bridge, allowing them to communicate and work together. Handling navigation and URL. By default, clicking a link in a web view might open the system's default browser. To keep users inside your app, you must intercept these navigation events. Android. Use a WebView client and override the should override URL loading method to control how URLs are handled. In iOS, use a WK navigation delegate and implement the decide policy for delegate method to allow or cancel navigation actions. This allows you to differentiate between internal links and external links. Internal links in staying in app, external links open in browser. Interacting with web content. The JavaScript interface. These powerful features allows for two-way communication between your native app and web page. Native to web. Your native code can execute JavaScript functions on the loaded web page, useful for passing data to the web UI or triggering actions. Web to native. Your web page's JavaScript can call methods in your native app code. This allows the web pages to trigger native functionality like showing a dialog, accessing sensors, or saving data. Security consideration. An improperly configured web view can expose your app and user to significant security risks. Limited scope. Only load URLs from a trusted allow list. Do not allow navigation to arbitrary websites. Disable JavaScript if unnecessary. If you are only displaying static content, disable JavaScript to reduce the attack surfaces. Set JavaScript enable false. This is syntax. Secure the bridge. Expose a minimal, strictly defined API through the JavaScript interface. Never expose sensitive native functionality. Prevent content injection. Sanitize any data passed from the web to native code to prevent cross-site scripting attacks. Performance optimization. Reviews can be memory and CPU intensive. Keep them fast and responsive with the techniques. Enable caching. Use a standard web caching policies to avoid re-downloading assets speed up subsequent loads. Optimize web content. The biggest wins comes from the web content itself. Minify JSS or CSS and compress images. Preload and warm up. You can initialize a web view in the background before it's needed to make it appear faster to the user. Advanced use cases. Hybrid applications. Building significant portions or even the entire app using web technologies hosted with a minimal native wrapper. Frameworks like Ionic and Cordova are based on this concept. Auth authentication. Securely displaying login flows from third-party services inside the app without directly handling the user's password. Rich content rendering. Using WebView's powerful rendering engine to display complex content that is difficult to create with the native components such as mathematical formulas, 3D graphics, or interaction charts. Debugging view. You can use standard web development tools to inspect and debug the content running inside your WebView. Android with Chrome. Enable debugging. Connect your device and navigate to Chrome in Chrome on your desktop. You get a full-featured console, network inspector, and more. iOS with Safari. Enable the web inspector in Safari setting on your iOS device. Connect your device to your Mac. In Safari on Mac OS, go to the Develop menu to find and inspect your app's web view. Best practices for web view development. Provide a native feed. Always shows a loading indicator, handle offline errors gracefully instead of showing a generic web page not available error. Do not replace native UI. Avoid using WebView for entire app navigation or toolbars. Use it for what it's good at, displaying web content. Version control your bridge. As your JavaScript interface evolves, ensure both the native and web themes are synced to avoid breaking changes. Ensure accessibility. Make sure the web content you display is accessible with proper semantic HTML and area attributes. Keep the component updated. Regularly update the WebView library system component to receive the latest security and performance enhancement. Conclusion. WebView is a powerful and flexible component that, when used correctly, enables developers to embed dynamic web content, reuse code, and accelerate development by understanding its capabilities, security considerations, and performance characteristics. You can effectively bridge the gap between web and mobile to create rich, engaging applications. Thanks. Good morning, Laura. Today we are going to discuss about the coding part. First one, package declaration. Uh, Declare the package name of your app. A package is like a folder that organizes your code, helps to avoid name conflicts with other apps. Kotlin import android.content.intent allows you to perform actions like opening a web page. Import android.uri. Uh, this handles the uniform resource identifiers. Import Next one is import Android OS uh, bundle. Use it to pass data between app screens and save state. Next one is import Android.widget button. Allows using button UI element. Next one is import Android.widget edit text. It allows using text input field. Next one is import Android.appcompact.app.appcompacted. Base class for activities that use modern Android features. And the next one is Import com.example.open web page app. Links your Kotlin code to the resources like layout files, images. Next, class declaration. Class main activity app compatibility. Defines a new activity called main activity. App compatibility provides a compatibility support for older Android versions. Activity is equal to a single screen in your app. Next, the declaring the UI element. Kotlin latent where edit text. This declares a variable edit text of type edit text. Latent intent tells Kotlin that we will initialize it later, not now. Edit text allows the user to enter a text like URL. On create function. Kotlin override on create. First method called when the app screen opens. Super.onCreate. This calls a parent class logic to properly start the activity. And the set content view. This connects the activity with its layout UI defined in XML, linking the UI element. Find view by ID finds the edit text widget in the layout using its ID. R.id.edit text refers to the ID of the edit text in activity main.xml. Now the Kotlin variable edit text is linked to the UI elements, defining the search function. Defines a function. Fun search is defines a function to open a web page. Value URL is equal to editText.string. This gets the text entered by the user and converts it to a string. Creates an intent to open the URL in a browser. Action view tells Android to view something. URI.parse URL converts the string into a link format. Start activity intent tells Android to start the activity. Open the browser with the URL. This app takes a URL input from the user and open it in a web browser. Uses edit text for input and intent for opening web pages. Main activity links UI and functionality. Next, the activity main file. First, it declares that this is an XML file. Encoding equal to UTF-8 ensures text characters are properly encoded. Second one is root layout XML. Android.constant layout widget.constant layout. Constant layout is a flexible layout that positions using constant. XML Android namespace for basic Android attributes. XML and app it namespace for custom attributes like constant. Next one is tools namespace for tool specific attributes only used in the design phase. Layout width layout takes full width of the screen. Layout height equal to match parent. Layout takes full height of the screen. Tools context equal to main activity. This shows which activity this layout belongs to preview. Next thing is the edit text. Edit text, a text input field for the user. Android ID gives the edit text a unique ID to reference in Kotlin layout. Layout width, which makes the edit text stretch across the screen width. Layout height is adjust to the content constraints. Top equal to parent. Top aligns with the top of parent layout. Bottom equal to bottom aligns with the bottom of the parent layout. Start equal to start underscore to start of equal to parent. Left aligns with the start of parent layout. End underscore to end of parent equal to parent. Right aligns with end of parent layout. These constants center the edit text vertically and horizontal. And the button search button. It is a clickable button for user actions. Android ID is a unique ID for the button. Android text is displayed on the button. Android on-click search, which calls the search function in Kotlin when clicked. Layout width and the layout height is previously we have discussed. Width is adjust to fit the text. Height is adjust to fit the text content. And the top bottom also we have discussed button placed below the text. Uh, bot, bottom underscore to bottom of equal to parent also we have discussed in the edit text. Bottom aligns with the parent bottom can stretch if we needed. This layout uses constant layout flexible and responsive. Edit text allows user to the type URL button equal triggers search functions when clicked. Constant position elements related to a parent and each other. Together, this layer creates a centered input field and button for this app. This this code is we have already run it and we will show the output. This is a screenshot of the output. Implicit example. HTTP refresh. Thank you.